Okay, so here are some exceptions to the octet rule. This is something we did not talk about in Honors Chem. So there are three types of situations where we have exceptions. One is where I have an ion or a molecule that ends up with an odd number of electrons. It doesn't happen much, but it does. Ions are molecules with less than a full octet, and ions are molecules with more than 8 valence electrons, an expanded octet around the central atom. Let's take a look at them one at a time. So these are rare, odd numbers of electrons. Here I have nitrogen monoxide, and it ends up with an odd number of electrons. Very rare, very unstable. Don't get asked much about this on the AP test. Now, I also have situations where I end up with fewer than 8 electrons. And if I do the formal charge thing, I end up with a negative charge on the central atom, which is never a good situation. So the other option is to end up with a neutral charge on the central atom, and a neutral formal charge, and have less than a full octet. Now, where you find less than a full octet is small atoms. Okay, so if you look at where boron is, it's you know, row 2, period 2, and it's got 3 valence electrons. So it's very small. So it kind of rationalizes that a small atom sometimes can't fit all 8. Okay, kind of a weak explanation, but that's the wisdom people use. Okay, so if you remember CNOPS, which is which atoms form double bonds, fluorine's not part of that group, so this is not a good structure. Okay, so for a couple of reasons we're going to know it's that. And more common is where you have an expanded octet. You have a central atom that ends up with more than 8 electrons, 2, 4, 6, 8, 10. And that does happen more commonly than the other two exceptions. So the only way PCl5 can go together is to have 10 electrons around it. Now, the only elements that can have an expanded octet are those that have d electrons. So the current wisdom is that you need d orbitals, even if they are unoccupied, that allows for this expanded octet. So what that means is anything in row 3, or now here it says 3 or below. So when we say 3 or below, we're talking about below it in the periodic table, not lower than 3 in number, right? So it's got to be at least the 3rd row, and phosphorus is the 3rd row. There are d orbitals here. They're not filled, right? But that's okay. So this only happens when you have an element that can handle an expanded octet, which means it has d orbitals, even if they are empty. Now, even though we could draw a structure where this phosphate ion has a expanded octet, the preferred structure is one where it has a double bond. Okay. Actually, there's 2 structures that work here. What happens here is the phosphorus ends up with a formal charge of +1. You want a formal charge in the center of 0. So here it is, everything looks nice and pretty, but here what you have is formal charge becomes 0, and you end up with an expanded octet, 1, 2, 3, 4, 5. Okay. So in the central atom, in the 3rd row or below, an expanding octet eliminates some formal charges. And by formal charges, again, we're talking about just that calculation. It's not an actual charge, but it's the formal charge calculation we talked about a couple slides earlier. We want that central atom to have a 0. Alright, so let's try drawing a Lewis structure for ICl4. So I is 7 valence electrons. 4-chlorine is going to be 7 times 4 is 28. That's going to be 35 plus 1 is 36. So if I have I have Cl, 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 and let me put bonds here, and I'm going to draw dashes instead of pairs because I am completely lazy. That means I have 8, 16, 24, 32. I only have 32, I need 36. The only option here is, none of these are CNOPs, right? CNOPs. You can't have a double bond with this chlorine. So what I end up having here is an expanded octet. Put my 2 extra electron pairs here. Okay, so which of the following is never found with more than an octet? SC or BR. So let's see, which is at least the 3rd period. Sulfur is, chlorine is not, and bromine is. So it could be with S or BR. Okay? How about XCF2? Kind of a strange one because we have a noble gas. It's got 8. Plus 2 fluorines makes 14, so that's 22. So noble gases do sometimes form compounds. It's rare, but it does happen. So if I have FXE, and I have my F, and I put my... What did I do there? That's just an F. Okay. And I end up with 8, 16, 18, 20. The only way this is going to work is if I put an expanded octet here. Okay? That's what has to happen. It's a big boy. You can do it.